Welcome back to my course Formal Methods for System Verification. So, in today's class we will learn conflict driven cross learning in DPLL based SAT solver. In the last class we have understood the basics of DPLL algorithm, what it does. Effectively you take decision about certain variables and that helps you to do the unit class resolution multiple times, which is called Boolean constant propagation. Once you do this and there is no further BCP is possible, you go back and take decision about next variable in the next decision level and it will again give you BCP. So, in this process if you get a full assignment you get the satisfactorily, right. But in most of the cases or many cases you will essentially reach a conflict that I have discussed in the previous class. In conflict is basically that partial assignment that you have taken so far is reached to a contradiction, some clause become false. So, what we have discussed in the previous class also that once you do this you have to erase this part of the decision and you have to restart the process. But the question here is that should we just blindly remove this part of the process and then restart the decide again, or I learn something from this. So, DPLL based method actually analyze this conflict and then learn something and also decide how much we should go back, that is by backtrack. So, we learn something from here, new clause, add to my clause sets and then I go back and do the process. Okay. In today's class, we will primarily learn this part of the DPLL. So, how do we basically analyze this conflict and how do we learn clauses, which is a good clause, how to get that good clause and so on. So, this example I have taken in the previous class. So, and this is the kind of conflict we obtain from these clauses. I can quickly recap. So, you initially take x6 equal to false at the decision level 1, which through this C8 forced to take x5 equal to false, right, otherwise this clause will become, so this is false. So, this must be true. So, it means x5 must be x5 should be false, then only x5 not of x5 will be true. And then we cannot take another decision. So, then I take x1 equal to true at decision level 3. Previously I have taken x7 equal to false, which is not leading to anything. Then I have taken x1 equal to true at the decision level 3, because this is the next decision level, and through which from C2 where x5 equal to false, x1 equal to false, so which x1 equal to true. So, this is false, which force me to take x3 equal to 1, right, to make this clause satisfiable through C2. Similarly, through C1, because x1 equal to true, so this will become false, which take x2 equal to true at decision level 3. And then from C3 where x2 equal to true, so which means this will be false, which make x4 equal to true at decision level 3. And then from C4 x4 equal to true, so this will become false, and x3 equal to true. So, this will also become false. So, this clause become false. So, I reach a conflict. Now, under this what are the questions is that this analyze conflicts return the new conflict clause and the decision level to which we need to backtrack. Okay. Is the conflict, so the question that I am going to ask you is that is the conflict clause is unique? Answer is no, we will have multiple conflict clause. So, how to find out the all clauses, or say how to identify the good clause, right, which is called the asserting clause, and then which one to pick is the asserting one. So, today I will probably discuss the way you will get answer to these questions. So, I have mentioned that once you have this conflict, I can actually, my objective is that I have taken certain decision, right. So, I have taken this decision and this decision, these are the 3 root node, but this is not contributing to this. So, I can ignore that. So, I have 2 decision x6 equal to false and x3 equal to 1 in 2 decision that leads to this contradiction or conflict, right. So, what I am saying that you can basically create a called separating cut, which is effectively cut this graph such a way that all the path from these root nodes to this conflict node cross through this cut, right. So, there are multiple possible cuts possible, right. So, this is one cut, I can cut like this way, right. So, you can see that the paths coming from this, there are many paths, right, there are 3 paths actually. So, if I cut here all this path getting cut. If I cut like this, then also this path get cuts. If I cut like this, then also all the path get cut from the root node, and if I cut like this, then also get this cut. So, I get kind of 4 cuts, 4 separating cut. Okay. And now for each separating cut, I can actually construct a conflict clause, and I have already told you that. Say for example, if you take say S4, what I am saying that, so the decision of x3 equal to true and x2 equal to true for creating this conflict. So, at least one of them should be opposite, right. So, this corresponding to x4, I have not of x3 or not of x2. So, this is the conflict clause I learned from S4. What about S3? Not of x3 or not of x1, right. If I consider S2, it is x5 and x3, right. So, it is x5 because negation of this or negation of this, not of x1. So, this is the clause I learned from this S2, and for S1 it is not x6 or not of x1. So, these are all conflict clause. So, a DPLL once you get a conflict, the first thing is that for each separating cut I will get a conflict clause. So, I have multiple conflict clause I can learn, but DPLL does not add all of them, they only add one of them, right. So, when I have multiple choice and you have to pick the clause, one of them you have to pick the good one, right, and the good one is basically called asserting clause. Okay. So, let us define what is asserting clause first. So, asserting clause is a specific type of specific class of conflict clause which has these two property, right. It basically say that in that clause C, which is asserting, you have only one literal from the current decision level. Okay. So, decision level I have already talked about, the current conflict happen in decision level 3, right, DL 3. So, my current decision level is 3. So, I will have only one literal from the current decision level, okay, and all other literal must be from other level, the below level, right, because this conflict happen is the current level which is the highest level, right. So, now if I go back to this example, is this a asserting clause? Here x3 and x3 both are in decision level 3. So, this is not asserting clause. What about this one, x3 and s1? X3 is in decision level 3, x1 is also decision level 1. So, this is also not. What about this one, x5 and x1? X5 in decision level 1 and x1 is decision level 3. So, only one of them is in decision level 3. So, this is an asserting clause. Similarly, here x6 and not x1. So, x1 is decision level 3, this is x1 1, this is also asserting clause. Okay. So, the steps I told that you basically can cut, you basically create a separating cut, so that all path get cut, all path from the root node to the conflict node get cuts, and for each separating cut you will get a conflict clause, and I will pick one of them. So, I will check which one is basically asserting clause, and I identify two of them is not asserting clause, two of them is asserting clause. So, I will pick one of them, right. So, you will just take either this one or that one, and then what I will do, I will basically erase everything to the second most decision level. So, my current decision level is 3 and 2 is not contributing here. So, any node which marked with 3 I will remove, right. So, I will effectively remove all this, this node, this node, this node, this node, this node. This is not anyway contributing. So, once I do this, I will get not of x6 at the rate 1 to not of x5 at the rate 1. So, only this part of the graph I will give, and this will also remain because this is not anyway part of this, right, x7 at the rate 2. So, this will be the my result and implication graph after analyzing this conflict, removing rest of the graph, and then I restart the process from here, right. So, this is what all about. Now, obviously, question is I am saying that which conflict clause to be picked is the asserting clause. Why I will pick asserting clause? Because it forces an immediate BCP, okay, or unit resolution after backtracking. So, backtracking is basically removing this part of this graph and keep this part, right. And I am saying that if you pick the asserting clause, then it definitely you will get an BCP after this. Okay. You do not need to take another decision immediately. Okay. So, this is why I am going to pick it. Now, the question is why is such, right? Why asserting clause ensure that this asserting clause force an immediate backtracking. Okay. So, this we should understand. Now, this comes from the definition of asserting clause. What I told you, the asserting clause contain only one literal from the current decision level, right. So, if the current decision level is D, I just keep only one of the literal from that, right. I have already explained. And how much I remove? Still the second most decision level, right. That means the only node, only literal from the current decision level is 1, right, and rest of the literal is from previous decision level, right, the previous one, and I remove everything from the current decision level and keep everything from the previous decision level. What does it mean? All the other variable of the new clause has already some value is assigned, right, which will make them false, because I have taken negation of that value, right. So, what will happen immediately, BCP can be applicable and it can remove the other literal that is from different previous assertion level, and it will effectively say that whatever the literal from the current decision level, it will assign a value to this, right. So, that is what I am saying, that at this point all lower level literal already have some false, right, the negation of these values. So, only the level D literal remain unassigned. So, if immediately this particular values will be applicable and BCP will work, and finally it assign the value to this new literal, right. So, that is why this asserting clause ensures that BCP occurs, right. I will show you with example also. Now, the first question is that how many clauses, conflict clauses we have understood. There are many conflict clauses, then which one to pick is the asserting clause. Now, the question is that how do I know which clause will result in an asserting clause, because if I just look into this graph, how do I know from this, right? I get 4 clauses, how do I know that? Should I compute all of them? That does not make sense, right? I should not compute all the clauses and then see which one is good, right? Instead, I should construct the asserting clause directly, right, without constructing all of them. So, how can we do that? The definition says that you pick the unique implication point, right. What is UIP? Is effectively says that a node in decision level D is unique implication point or UIP of this level. So, for each decision level there is a UIP, right. For every decision level you will get different UIP. If it occurs in each path from decision dth decision level literal to this conflict. Okay. So, it is basically a special type of node which occurs in every path from that particular decision level node to the conflict node. Let us understand. So, in my example I have 2 decision level, right. So, I have x1 at decision level 3 and x6 equal to false in decision level 1. This leads to this conflict, right. So, what I am saying here, what is UIP? For each decision level I have a UIP, I can have multiple UIPs, right. So, what I am saying that from this node to this conflict node, how many paths are there? We have effectively one path. So, what I am saying that any node of this decision level, so there are only 2 nodes, right, of this decision level, a node of x6 in decision level 1 and node x5 in decision level 1. I will say that any node that in all the paths from this node to this node, since we have one path, all of these nodes are UIPs, right. So, this is also UIP, this is also UIP, this is also UIP, this is also UIP. I will say this is UIP 1, this is UIP 2. Why? The UIP 1 is the one which is closest to the conflict node. So, similarly, I will get UIP corresponding to this row node. How many paths are here? I have, how many paths are here? I have 1 path and 2 path, right. So, for this how many UIP is there? So, by definition of UIP it is all the paths from this root node to this node should happen. But now, if you consider this node, is it UIP? No, because there is another path in which this does not occur, right. Similarly, if I consider this node, this is also not UIP, right. This is also not UIP because there is another path in which this does not occur. Similarly, this is also not UIP. So, the only one UIP is here is this node, right. So, this is the only UIP corresponding to this decision level, and this is UIP 1. Okay. So, we understood what is UIP. Okay. So, let us conclude here. So, in this graph, as I already say that x 3 is not an UIP because there is another path here which is not covering here. So, this is not UIP. X 5 is UIP, yes, this is for corresponding to decision level 1. X 6 an UIP, yes, because this is corresponding to decision level 1. X 3 an UIP corresponding to decision level 3. So, there are 3 UIPs, right. So, we understood what is UIP. Now, I have already defined what is first UIP, which is the closest one to the conflict node. So, if you see here, for this I have only one UIP, so this is UIP 1. For this decision level 1, there are 2 UIP, so this is UIP 1 because this is closest to the conflict node. Okay. Now, what I am saying here is that we are saying that you pick the card that contains this first UIP. Okay. So, what I am saying that you basically pick a clause that has the first UIP of this current decision level. Okay. So, the current decision level is 3. So, either I will pick this cut or this cut, right. So, both of them will give me the asserting clause, and I have already seen that those are 2 asserting clause, right. So, these are the 2 corresponding to S 1 and S 2 are the asserting clause. The other cuts, which is say S 3 and S 4, they are not asserting clause because they are not considering the UIP of the current decision level. Okay. So, why I am going to choose the first UIP, why not the second UIP or others? Because first definitely the first UIP is producing the asserting clause, right. So, this I have seen that. It also this is the nearest to the conflict node. So, if I do the backtracking from this, this is the nearest one to track, right. So, as I seen here, I get both of them is asserting. So, for corresponding to S 1 and S 2, both are basically asserting clause, and if I start from this node, I will get this cut first, right. So, I will basically get this on the first UIP 1. So, I will basically, this is the earliest one I can give. So, unnecessary search I can avoid and I can make my process faster, right. Similarly, this clause is the smallest one because I do the minimum backtracking. Okay. So, the new clause that I will get is smaller one, and in subsequent class I will show you smaller clause actually helps in this decision making process because you can do a immediate BCP on that, right. So, effectively if you take the first UIP, it guarantees asserting clause, it is computation efficient because you get it immediately or very this is the easiest the earliest one you will get, and it also give you a smaller clause which is better, right. So, that is why it is improved efficiency. Okay. So, why this is giving smaller one, let us try to understand with the example. Okay. So, let us consider this particular conflict. Let us say I have taken many decision x 2 at the decision level 2, x 4 at the decision level 7, x 5 at the decision level 8, x 1 at the decision level 4, and this lead up to this conflict. Okay. Okay. So, now let us see the UIPs. Okay. For decision level 8, how many paths are there? There are many paths here, right. So, this is one path, path 1, this is path 2, this is corresponding to decision level 8 I am talking about. This is another one, right. So, this is path 3, then this is path 4. So, there are 4 paths from root node of the decision level 8 to this conflict. Okay. And the UIP is those which basically falls in all paths. So, I can clearly see that this is UIP and this is a UIP, right. These nodes are not UIPs because they are not in all paths. So, I have 2 UIP, I am saying this is UIP 1 and this is UIP 2. Similarly, for other node they have single UIP. So, this is the UIP, this is UIP, this is also UIP, right. So, for other node this is also for this node, this is also UIP, but let us not focus on that. I am basically talking about the UIP of the current decision level. So, decision level is here 8, conflict happening decision level 8. Okay. So, what I am saying that the asserting clause will take the first UIP, right, of the current decision level which is 8. Okay. Now, let us try to construct the asserting clause corresponding to the first UIP and the second UIP of the current decision level. Okay. So, the cut here is shown is actually wrong. So, actual cut will be is this, right. So, this is the cut 1 effectively, right, because now all path from all root node will be blocked here, right. So, what is the clause I will get here, which is not of x 2 or not of x 6 or not of x 4, right. This is the conflict clause I will get, and this is asserting clause because I have already discussed that it consists the first UIP. If I consider the other cut, right, so which is this one, right. You remember the cut has to such that all root nodes should be in other side and conflict should be on another side. There are 4 root nodes here, all 4 has to be avoided here, right. You have to consider here. So, what is for cut 2, what is the conflict clause? You can see here not of x 2, then not of x 4, not of x 5, then not of x 1. You can see here this is size is 3, this is 4. So, why this is happening? Because other root node occurs here, right, x 2 and x 1, x 2 and here this is not of x 2, not of x 6 and not of x 1, sorry, this is not of x 1. So, other root node are present here, here and here, right, x not of x 2, not of x 1. The problem is that the first UIP, it ensures that this is the only literal from this level, right. If you go up, this root node also come into picture, right. In this cut, I do not have to take this root node, but when you go up, the other particular literal also coming. So, because this is getting rewritten if you go up, right. So, that is why I told you that if you take the first UIP, it will give you a smaller clause. Okay. So, this is what I have written here. So, this is the smaller clause. Now, the question is that why the clause related to UIP is the asserting clause. This is also interesting question, right. So, I have seen that this is asserting clause, but why this is going to happen all the time? Why this will, it is not an asserting clause also, right. This is because if you look it closely, what is the definition of this first UIP? What I am saying that this is the nearest to the conflict node and UIP covers every path from the root node of this decision level to this, right. Now, if you construct the clause here, the only node coming from the current level is this node, right. So, that is why this is asserting clause, right, because I told you in asserting clause you have only one literal from the current decision level, which is 8. So, if you construct the first, if you take the first UIP, other nodes that are coming here, they are from other decision level, the only one literal coming from this level. So, definitely this is asserting clause, right, because that is the by definition is asserting clause. So, this way this is, so the for UIP 1, the only one literal coming from the current decision level, the only one literal is coming from the current decision level, and this is the requirement of the asserting clause. Okay. So, once you take this decision, as I mentioned earlier, I will keep this part of this, as I mentioned, I will only keep this part of the circuit of this implication graph, and I have already shown this in the previous class that if you, so basically this part will be remain 1 and then C9, which I learned immediately, will result in a BCP, right, and this will result in this, and then from C5 and I will basically get this one, and then from this x 2 equal to false from C6 I will get this BCP, and from this I will get another conflict. So, I have already discussed this in detail in the previous class, and now once you get this, again I can actually check what is UIP, right. So, my conflict happened in decision level 1, right. So, now if I cut it here, so what are the UIPs here? Let us first mark the UIPs. Okay. So, let us mark the UIPs first. So, here you have only one decision node, which is this is the root node, this is the conflict node, and there are many paths, right, and you have to make sure that EIP is in the in all paths. So, definitely this is not UIP, because there are some path going like this, which is not coming here, but this is UIP, right, this is UIP 1, because you see this is one path, this is another path, right, and there are many other paths, but everybody will going through this path, this node, right. So, this is the basically UIP. Similarly, this is not UIP, you can clearly understood, because this is some path is coming through this, but this is also UIP, right, this is UIP 2 and root node is always UIP. So, for this conflict node I have 3 UIPs, and I told you that once you have this, I try to get the separating clause that constitutes the first UIP. So, this will be my cut, right. With this cut, what is the clause I will get? Negation of this, which is x 2. So, after constructing this, I learn the clause x 2, and that is my C 10 that I will add to my previous thing. And then in this case, I will remove everything, because all nodes are of decision level 1. So, I will remove the entire graph and I will restart the process, right, from decision level 0. So, this will go on. In the next class, what I will do, I will show you that how to effectively construct this x 2 automatically, right. So, this part I will show, and then I will explain the overall algorithm and the termination correctness of the algorithm, and then I will conclude this SAT solver. Okay. Thank you.